All right, hi folks. Going to give you a recording for Wednesday's lesson, especially since juniors missed second period and seniors missed third period. So a good number of you will not be in class to see this. I promised you this would be short. So here goes. We're sticking with normal calculations, but we are going to ramp them up a little bit and make them a little more interesting by throwing in a system of equations. Yay! So typically what happens in a situation like this is we'll have a normal model, but we won't know mu and we won't know sigma. But we should have two situations within the same normal model that we can write two equations from with two unknowns and then do what we do to find those unknowns. So when you read this, what the trick here is to get the curves drawn right. And some of you guys aren't drawing curves, and that is not to be to your benefit. I think you're making a poor choice. It only takes a second, and then you know where you are in your normal model. A lot of times you do, but occasionally you don't, and that's just fodder for mistakes. So here it says, while only 5% of babies had learned to walk by 10 months, 10 is kind of a target here. If you compare it to the next one, the next situation here, 75% have learned, there should be an L here, who writes these things, have learned to walk by age 13 months, okay? So 13 months comes after 10. I'm thinking 10 is on the left side of the curve, 13 is on the right side of the curve. So that's where I'm going to start. I'm going to start with the first phrase, and I'm just going to build a normal curve out of it. So only 5% of babies have learned to walk by the age of 10 months, all right? That's kind of a big 5%, but let's just label it. It doesn't really have to be to scale. So 5% have, but 95% haven't. So you want to get the z-score right here. So that'll be inverse norm 0.05, and that will give you negative 1.645. That's a very common number when we work with these z-scores. And so now that we have that, this is going to be treated like an x, and this is going to be our z, and mu and sigma are just going to be our placeholders. So we can go ahead and say that 10 minus mu over sigma equals negative 1.645. All right? There's an equation, two unknowns. We'll fix that fraction in a moment. So then we'll go over to the second phrase, and it says 75% have learned to walk by the age of 13 months. Okay? So here, this is 0.75 have learned and 0.25 haven't. All right? So you should already know what this is, because this is, remember, Q3. So your z-score here should be 0.6745. Remember that? 0.6745. So the 13 will be the x in the second equation. So 13 minus mu over sigma equals 0.6745. So right there is your second equation. So now what we want to do is to get both of these in standard form. And standard form for a linear equation is ax plus by equals c. That way we can line them up and do elimination on them. So I'm going to multiply each side here by sigma. Start out with this equation. So 10 minus mu equals negative 1.645 sigma. And now I'm not going to do this like I'm teaching an Algebra 1 class. I want this in order in a standard form. So I'm just going to say negative mu, and then I'm going to add that negative 1.645 sigma over, so plus 1.645 sigma. And then I'm going to subtract the 10 the other way, so equals negative 10. All right? So then here for this one, I'm going to do the same thing. Multiply that by sigma, multiply that by sigma. So 13 minus mu equals 0.67. 0.6745 sigma. And I'm going to do the same rearranging. Negative mu, I'm going to subtract that over, so minus 0.6745 sigma. Then I'm going to subtract the 13 the other way, equals negative 13. Now it lines up. Now I just don't have the best match here with this. I want them to have opposite signs. So the easy fix would be to just multiply that by negative 1. And so that'll change all of those signs. So mu plus 0.6745 sigma equals 13. Now I can put that right here. Now it's good for elimination, right? Because the mu goes to 0. The sigma terms add up to, let's see, 2.319 sigma. And this adds up to 3. So divide each side by 2.319. And you get what sigma is, because that cancels out. So sigma equals, and that'll be 1.2934 months. And that is in months. It's in the same metric as the original data. Let me get that letter right. All right? So halfway through the battle. Now the second part of the battle is actually pretty easy because all we have to do is substitute this in, maybe like right there, and solve for mu. So mu plus 0.6745 times 1.2934 equals 13. Remember, we're working off this equation. We're just replacing sigma with its actual value. So you add those together and subtract from 13, or I'm sorry, multiply those together and subtract from 13, and you get mu equals 12.1276 months. So this is effectively done. So what we get now is that this is normally distributed with a mean of 12.1276 and a standard deviation of 1.2934. There it is. That's it. Now we may differ a little bit in our rounding, so we may be slightly off, but I'm pretty forgiving about that. It's not the biggest deal in the world. You just have to be in close proximity. Let's call it that. All right? So there it is. Let's box this in and go on to the next one. Okay. So wildlife biologists believe that the weights of adult trouts can be described by a normal model. So again, it's normal with some mu and some sigma. Fishermen report that 22% of all trout caught were thrown back because they weigh below the 2-pound minimum. And since the other value they give you is 5, I'm thinking that that's the left side of your curve. Okay? All right, so this will be 0.22 and this will be 0.78. So we need to do an inverse norm. Remember, it's left to right to the cut line. 0.22, and that will give you negative 0.7722. All right, good. So we can use this as an x value. So we'll just say that 2 minus mu over sigma equals negative 0.7722. All right, that's the first equation. And that comes from that first phrase. And then the second one, only 6% weighed over 5 pounds. All right, that puts your 0.6 here, 0.06 rather, and 0.94 on the other side. All right, so this z-score is going to be inverse norm 0.94, which will give you 1.555. All right, I know I'm being a little bit non-conforming with both of these, like this is 4 decimals and this is 3, but we'll get enough accuracy here. All right, so 5 pounds will be the x for the second equation. So 5 minus mu over sigma equals 1.555. Okay, so multiply each side by sigma, just like we did up top. So 5 minus mu equals 1.555 sigma. And I'm going to play some tricks here. So the opposite of mu, I'm just going to leave that there. I'm going to subtract the 1.555 sigma over and subtract the 5 the other way. All right, then over here, I'm going to multiply each side by sigma. All right, so that'll be 2 minus mu equals negative 0.7722 sigma. And rearrange it, so negative mu equals, oh, don't want equals there, let's get that out of there. Plus, I'm going to add this over, so plus 0.7722 sigma, subtract the 2 the other way. And to make these things match, I'm going to multiply this by negative 1, right? So I'm going to get mu plus 1.555 sigma equals 5. All right? And that's ready to add down. All right? So the total for this will be 2.3272 sigma equals 3. And divide out the 2.3272 to both sides. And you get an answer for sigma. Sigma is going to be 1.2891 pounds, which we'll put in right there. So mu plus 1.555 times 1.2891 equals 5. And when you get all done with that, mu is going to equal 2.9954 pounds. So this will be normally distributed with a mean of 2.9954 and a standard deviation of 1.2891. So that's how it works. So those are the notes that you missed, and I think the rest of the period we're going to work on another problem or two, maybe the first one on the homework for Wednesday, which is, I think, people buying groceries. And so look at the keys. If you get confused, look at the keys. That's why I post them. All right, so it's raining like crazy. I'm expecting the power to go off at any moment, so I am going to call this quits, and we will convene soon.